All right, it's last session of the day. I think we're scheduled to kick off at 1:15. I was going to wait a couple of minutes, give folks a chance to come up from lunch. But I'd like to introduce our next speaker. And forgive me if I pronounced your name wrong. Koji Ishikawa?
Yes, that's right.
Okay, I got it right. Who works for Horiba Instruments. And he is an R&D application specialist. His background, he graduated from Nagoya University with a master's program. How long ago was that? Huh? How long ago did you get your master's degree?
Chemical.
Chemical engineering? Yeah. After graduating, he worked at Horiba in Japan for 15 years and then transferred to Houston in 2018. And he is part of the analyzer development team. His hobbies include surfing, hiking, and traveling. And with that, I will hand it over to you. Oh, I should introduce the title, Real-Time Measurement of Impurities in Ethylene Production using a process laser analyzer with infrared absorption modulation. Arrows will move you backwards and forwards. Right. And you're good to go.
Good morning, everybody. Good afternoon, everybody. Thank you for introducing, and also thank you for taking a time today, joining today. So my name is Koji Ishikawa. My presentation title is Real-Time Measurement of Impurity in Ethylene Production and the Carbon Neutral using a process laser gas analyzer with infrared laser absorption modulation. So I would like to share that's okay. So this is my agenda. Firstly, I wanna share my background of this development, and also I would like to introduce my laser gas analyzer. It's called PLGA 1000. And also, that's the unique technology, IRLAM, I would like to explain later. And also, I want to share the test result in the laboratory and also field trial in the ethylene plant. And then we are also developing for other application. That's why I introduce our application development. So firstly, this is my background of the development. So we are focusing on the ethylene production. As you know, ethylene is the largest feedstock for the petrochemical industry, reaching more than 226 million tons in 2023. So this production is by stream cracking or thermal decomposition of the ethane. Ethylene is a starting chemical for the many other products that need purity above 99.95%. And then ethylene, C2H2, is a byproduct production during hydrocarbon cracking in the ethylene plant furnace. So ethylene contamination level is very trace, like 10 ppm to or 0.5 ppm. So that is our target and background. And then we have the two key applications. We are focusing on two key applications. So one is the ethylene converter. So ethylene converter is a highly heterotoxic reaction. So careful control of the reaction temperature is critical to the plant safety. So integrated reactor safety system is essential for the safe operation of the ethylene plant. And our target measurement component are methane, ethane, and also CO. So we can measure that's 4 component and target component that's 4 component. And also this table showing our target specification, the whole component. So methane, ethane, ethylene, and CO. So ethylene converter for inlet, outlet, and also mid-bed. So that's why, especially focusing on ethylene converter outlet, it's targeted less than 10 ppm. That is the most important. And also other control component like CO for the safety, and also high concentration ethylene for the inlet of the converter. That is our target specification. And also each performance specification are there. So, and also we have the one more key application. So second one is a seat splitter. So that one is the production for the ethylene, just separation of the ethylene from the ethane. So that is the final step of the production of the ethylene. That one also have to monitor the impurity of the like these components, methane, ethane, and ethylene, and the CO2 as well. And also that is a specification for 4 components: methane, ethane, ethylene, and CO2. Then performance specification is the same as the ethylene converter. So our target is performance level is the same as the both applications. That is a target specification. And then from this slide, I wanna explain our product. So process laser gas analyzer, it's called the PLGA 1000. It has a many advantage in the gas sensing. So high resolution using a mid-infrared laser system, and also fast response, 3-second analysis time. That is a quick response. And also high sensitivity. The 20 ppb is a minimum measurement range. And also just one single enclosure has up to 6 lasers. There is a maximum laser, maximum 6. And also this analyzer has a robust, simple, and compact design. And there is one more advantage: high sensitivity by the unique interference correction method. That is our feature of this analyzer. And then this is a designing specification. We have the class 1 division 2 and also ATC hazardous area classification, and also 2 channel of the DCS, 2 Modbus, and then the other 1 channel for the maintenance. Total 3 channel of the Modbus. That means that this analyzer can do the redundant monitoring. And also sometimes customer asking analog output and digital output. So that is this is a designing specification. And I can show you that production concept. So top left hand is outline the picture of the analyzer, and then left bottom one is open the door, just internal analyzer. So our key component, optical unit, that's a right hand. So this figure just showing the whole QCL, whole laser configuration. So we have the whole laser right now, and then each laser emits each laser to the lens and the filter unit, and also go up to the laser unit, and then we have the helio cell, and back to the detector. That is our optical unit design. And also, we have the key components. So one is the quantum cascade laser. So this quantum cascade laser made by Horiba, Japan, and in Kyoto. And also, this QCL laser is semiconductor laser invented in 1994, which can emit from the mid-infrared to the terahertz. So the operating wavelengths can be selected by designing the structure of the material. That is our capability of this manufacturing. Wavelengths are adjusted approximately for each gas application. That is our strong point. Then all equipment, all key QCL made by in Horiba, Japan. That is strong. And also one more key parts. So this is a helio cell. It has a path length of the 5 meters with a cell volume only just 40 milliliter. That small cell volume allows the gas to be replacement rapidly, which is a benefit for the analysis speed and response time. In addition, about the surface area is very small. So that means the risk of the absorption can be reduced. That design is compact and then suitable for the field replacement. That means service, and then easy maintenance. That is our benefit. Okay, and then from this slide, I want to explain our technology. Infrared laser absorption modulation, it's called IRLAM. So IRLAM is the method for the data collection and analysis. So Horiba is capable of this manufacturing, QCL scan with current to collect data, 500 data point per laser. And then spectrum feature extracted from the sample spectra. And known spectrum are compared to the sample spectrum in known database to determine concentration. So spectrum interference such as band broadening, temperature and pressure influence are compensated by extracting the future quantity related to the disturbance. So calculation speed and accuracy are drastically improved. So this is a general talking. So just talking about a laser gas analyzer. So IRLAM is absorption method of the IR. So each component has the absorption wavelengths corresponding to the band. The laser has a high wavelength resolution. They can scan narrow area like a blue dot square. Then we can target sample absorption while designing to them minimize spectral interference. IRLAM has the advantage of this compensation of the temperature, pressure, and the spectral interference effect. So as you know, so IR measurement has the interference and the coexisting effect. So we need to care two effects, interference and the coexisting effect. So the problem is when the balance gas is changed by the percentage level, the shape of the spectrum also gets fatter or skinny. That is a broadband, coexisting effect. So when the QCL scan the wavelengths, the phenomena need to be corrected, compensated. So it's called the broadbanding effect for the coexisting effect. So this slide showing the comparison between NDIR and IRLAM. So left side showing the NDIR, and then it has a thermal light source, gas cell, and detector. So NDIR has the absorption spectrum and also converted to detector signal. So then versus the wavelength, x-axis always showing the wavelength, and the other hand, IRLAM. That is a big difference. X-axis, so x-axis is always time, not wavelength. That is the difference. And also, calculation method, in the calculation method, IRLAM can use the future reference signal. That is a difference. So I will explain that reference signal. So this is a future quantity can be obtained by the sum of product of the absorption signal and the future reference signal. So if the shape of the similar, the future value become large. If the shape are not similar, the future value become smaller. Since this future quantity is proportional to the concentration, it can be quantified while assigning the value based on the concentration at the time the future quantity acquired. So left side showing the just sample absorption signal. So as I say, the x-axis is the time. So just taking a time, 500 data point. So, and then we set the future reference signal, F1, F2, F3, and F4. F1 is a sampling target component, for example, ethylene, C2H2. And then F2 means interference. It has ethylene or ethane and the methane. That's the interference gas. We set F2. And then if we set F3 is a temperature, like a temperature. If temperature changes, the signal also changes, like a shifted. And also F4 means the broadening. It's like a pressure. So we acquire these data before shipment, before to the customer site. And then we need to create a database. So we set like a F1, F2, F3, F4. So left table showing creating a database. So flowing a sample target gas, ethylene, keeping a same concentration like a 10 ppm, and then broadening, it's a pressure, it's changed, high to low. That's why S1, S2, S3, S4, that is a signal. So if change the broadening, if change the pressure, F4 is high and then F4 is low. And also wave number shift, it's a temperature. So we change negative temperature and positive temperature. So S3 is changed, but S1, S2, S4 is same. So we need to create that database. Then right table, same mean, we flowing the interference gas, like ethylene, methane. And then we change the pressure, we change the temperature. That is our database in creating our facility first. And then this is an actual calculation. IRLAM applied the matrix operation as described here. Okay, this table showing that test result in our laboratory first. So right upside is showing us stability data for the ethylene C2H2, almost 1 day data, 24 hours. So we feeding the nitrogen. So, and then error, noise level is almost plus minus 0.1, 0.2 ppm. And then we tested vibration, X direction and Y, Z direction. So this data showing it's stable. So that's why our alignment issue is nothing. No change alignments. That is the one data for the stability and the vibration. And next one is the response time. So firstly, we are feeding a zero gas, nitrogen, and then switch to span. Span is a blending gas. Blue one is the ethylene. Orange one is the CO2. So blending gas, 2,000 ppm methane, 50 ppm ethylene, 25% ethane, 10.8 ppm CO2 in the balanced ethylene. That is the blending gas for the span. So just switching 0 to span. So left graph showing the response time almost 3 seconds, within 3 seconds. And also switch to span to 0, and then same data, same response time within 3 seconds. And also, I'm going to share that data. This is a field trial data in the actual customer ethylene plant. So we tested, we installed our analyzer, and then taking the data, we have the 4 laser unit. Orange one is the ethane, gray one is the ethylene, and yellow one is the CO2, blue one is the methane. Then one digit is almost 30 minutes. So we testing around 6 a.m. in the morning. Suddenly, blue one is spiking up, normally almost 300, 400 ppm, but around 6 a.m. spiking to the 6,000. It is upset condition of the actual plant. And then at that time, ethylene and the CO2 is stable. It means no interference, no effect of the high concentration of the methane. That means we can achieve the good performance of the interference reduction, interference effect reduction. And also, orange one, ethane is fluctuating almost 25%, and then still our analyzer can catch that fluctuation. That is one good result of the field trial. And then this is another day. It's the same field trial, and then another day, upper graph showing our same data. And then x-axis is the time, almost 1 day. And also bottom one is just comparison, another general QCL, not our analyzer. This is a general QCL and also GC data. So color is same. Measurement component, orange is ethane, gray is ethylene, yellow CO2, and blue is methane. And then just same sample point, then taking the data. So our upper side, our data showing 6 a.m. methane is spiking up, and also gray, yellow, CO2 and the ethylene is stable. It's no effect. But at bottom one, it has fluctuated. So yellow, especially yellow CO2 has a very random noise. So that's why general QCL has some interference or some effect, but our QCL analyzer is no effect. That is a good result also. And different data, this is March 2nd. Around 7:30 a.m., it was the same as spike of the methane. Spike up to around 800 ppm, but CO2 and ethylene, gray and yellow is stable. That is a good result as well. So we can achieve the development for the ethylene plant for the impurity measurement. And then we are keeping developing to the other application. So this one is one of new application. This is a carbon capture. After capturing the CO2, can measure the impurity. So background gas is a CO2. It's a rich CO2, and then can measure NO 50 ppm, NO2 50 ppm, and SO2 50 ppm. That is the impurity for the carbon capture process to inject on the pipeline to protect the corrosion or utilization for the catalyst. So we can achieve that application, and then measurement noise level almost 0.02 ppm for the NO, and NO2 0.005. It's very benefit for direct measurement. So traditionally, NOx measurement using a chemiluminescence with NOx converter. But a NOx converter has some error, some efficiency error. So that's why if they want to measure more trace level, laser gas analyzer is an advantage for that direct measurement. That is one of application development. And then the other application is a semiconductor facility. So recently, increasing the build of the semiconductor facility. So this is a application is exhaust gas for the abatement process. And then they want to measure HF, HCl, and the NO2. So this is a similar with the SEMS application. So that's why don't need a quick response. So that's why this specification is almost within 30 seconds. And then HF and HCl is 10 ppm, less than 10 ppm. So this one also we can develop that application using IRLAM technology. That is one of application development. And then this is the final presentation, the conclusion. So we developed a new gas analyzer and then technology IRLAM. So achieved the high sensitivity and fast response. And final trial test in the ethylene plant was a good result. And also achieved impurity measurement in the new market, carbon neutral and also semiconductor. And then next, we want to expand more component like other component and also application. Thank you so much.
Anybody have a question for Koji? No? Okay, then we are good. Thank you very much.
Thank you so much.
Appreciate you coming and speaking with us. There's something for you.
Thank you.
All right, we're going to, that was the final technical paper. If you have score sheets that you filled out from this morning, if I could get you to pass them into the middle, I'll come by and pick those up so that I can tabulate numbers during the next presentation. If you give us a minute or two here, we're going to switch out machines. Okay, so our next presentation is going to be given by, and I'm going to do the pronunciation correctly. Glenn Cudiamat. Glenn works and is the president and CEO of a company called TDA Research. He's got a bachelor's degree in chemistry. Good man, so do I. From Loyola Marymount University in California, and has been working in this space of market research now for quite some time. We used to have, for those that have been coming here a long time, Steve Walton and Terry McMahon used to do this, and then in about 10 years ago, Glenn partnered with them and has now become I guess the sole proprietor of this market research. He's done this for labs, life science, automation, and now is in our process analytical instrumentation space. So he's here to give us the latest and greatest on what the business world is looking like. His hobbies include reading, visiting family, friends back in Hawaii, and this one, guilty pleasure, is watching K-movies. I don't even know what that is. Korean dramas and kung fu movies. So I hope you don't have a black belt, and please be nice to me. So, having said all that, I'm going to turn it over to Glenn, and I'm going to get out of the way.
Thank you, Paul. My talk's very different from maybe the ones you've heard throughout the week. I'm much more marketing oriented than technical. But yeah, thank you for attending my session. But before we go through, I always have to do this disclaimer, just for insurance purposes. See. So my goal is that you take at least one thing home with you. I want to tell you a lot about the PAI market, ways to understand it, and basically, what's driving purchasing decisions and purchasing behaviors. This presentation will only focus on the macros and the vendor survey. So here's an outline of my presentation. We'll talk about the macros and what it's telling us and how those tariffs are likely to disrupt the market. We'll look at the data from a vendor survey we recently did in Q1, and finally show you some data on the PAI market. Okay, but before I go into the data, I wanted to give you a sense of what we do. This is the like and subscribe part. Anyway, if you don't already know, we do market research specifically for scientific markets. Simply put, we collect, analyze, and report data. We focus on scientific markets. We cover 3 domains: lab, process analytical, and lab furniture. Overall, we cover about $75 billion spread across 10 sectors, 63 technologies, and 231 product categories. So what's an ATC presentation without a flowchart? So this is my attempt here. The core of what we do is trying to understand behavior, and specifically purchasing behavior. So it's like the tariff policies, it's always changing. There's four key aspects of behavior. It's awareness, what's the best to reach customers; interest, what's the level of interest potential customers have; desire, or how do you turn interest into desire, want, and need; and action, what will drive those actions, purchasing decisions, what are stopping them? Do you have the right prices, the specs, the solution? Is it easy to use, easy to maintain? And how you do this is by understanding the end user and vendors, and the way we do it is just asking, doing surveys. Okay. Another good way to look at and monitor behaviors is to look at the macros. The way to do this is to understand the types of data available and the timing and its correlation to the industry. They give you clues. It's about understanding those inputs and outputs. For example, income and spending. For most Americans, we love spending, and most of us have to borrow money to spend. You might have the same experience as me, but my adult kids seem to conflate income and borrowing. Borrowing is why our national debt is at $36 trillion. And in fact, nearly 80% of us are in some kind of debt. So that's just the American way. Anyways, ways to look at the data is to understand the relationship between manufacturing and consumption, and understanding its energy and the economics that goes into, that brings a product from farm to table. So the macros should, what macros should you look at? On the input side, it's employment, industrial production, energy, and those are the things that will give you some clues. On the output side, it's currency, GDP, inflation, trade data. Yeah. Okay, so what are the macros telling us? Here's some headlines about the tariffs and duties from the past week. So before I go into that data, there's a new tool out there that some of you guys are using. Maybe you've heard of it. It's called AI. Like a child with a new toy, I wanted to demonstrate its power and utility. And so, of course, the 5-year-old boy in me couldn't pass on creating puns related to tariffs and duties. I prompted AI to generate headlines related to a TV show, video game, and lastly, our energy sector. And here are some of the results. If you watch White Lotus, Season 1, Episode 6, you might find the first one amusing. If you're number two is somewhat clever. And for our industry, I picked 2 headlines, Duty Blues, hydrogen caught in tax turmoil, and Duty Blows, wind energy stinks. Okay. Okay, so back to the macros. This one I showed last year as well, but it's good to keep tabs on it. This is industrial production index. It is the measure of the physical output of manufacturing, mining, and utilities sectors. The index is used as an indicator of the health of the overall US economy, where changes in production levels can signal changes in demand and employment. The chart shows data from February 2020, right before the pandemic, and through February 2025. So in case you're wondering, that line in the middle is when the Russia-Ukraine war started as sort of a reference point. You can look at the end of the last year there. We see positive slope indicating strong momentum coming into 2025. And I attributed that to a lot of return to work economy. So like very big push to getting back to the office. But in March and April, things started to change. So what's good is that in our last job report, we added 228,000 jobs. But only 1,000 of that was because of the manufacturing sector. Moreover, the unemployment ticked upward from the previous months, which is not a good sign. Okay. If you don't monitor the Purchasing Managers Index, this is probably something you should put on your radar. This is based on a survey of the largest manufacturers, and it tells us what consumers are spending, or if the consumers are spending. Participants are asked to gauge activity on new orders, inventory, employment, supplier deliveries, production. And the way to read this is to look at that score. Anything above 50 is good, anything below 50, not so good. So focusing on the right-hand side of the chart, we see a negative slope, dipping below 50 in March. So as soon as new administration comes into office, the tariffs were announced, and you can see the manufacturers start to pull back. Okay. So here's the latest GDP and inflation data from the IMF, just published a couple of weeks ago or last week. So what I did was I overlaid their October forecast with the one in April. And what we do is we pay attention to the subtle changes in the numbers. So inflections of 0.1% is significant to us, and that's when I take a look and go see what they're seeing. So they've revised 2025 to 2020 and 2026 downward, and if you notice in the shape of that graph, though, what is it? It's not like a pulse from like what you saw in COVID, right? It's a spike downward and then an upward, but essentially what we're doing is we're losing about 0.4 and 0.3 points in GDP. That means production. So all that goes into those 2 years is just lost. Okay. So moving to inflation, the right side of the chart there, or the slide, I've overlaid the October and April, and basically there's no meaningful change. So this goes to pricing, but what we want to see, if you look at 2025, 4.3 is still pretty high, and 3.6 is sort of where we want to be at. So in terms of if you're going to increase prices, do it now, or you'll start to see increased prices as well. Okay. So let's briefly look at currency, so exchange rates. I've plotted exchange rates of some key geographies. So the euro, Chinese yuan, Japanese yen, Canadian dollar, and the Mexican peso. Basically, the graph shows the US dollar weakening. So if you were to travel to Japan, the cost would be a little bit more expensive compared to last year. But if you were in Japan buying American goods, then your yen would buy something, you'll buy slightly more goods. Let's look at energy prices. Crude oil, that's the blue line, is forecasted to average about $64 a year, while natural gas, the orange line, is expected to nearly double, reaching over $4 per million BTU. So for us, it kind of translates to the different analyzers that would do well because of these changes. So yeah. Okay. So let's look at import and export values. This is related to tariffs, right? Perhaps the most relevant to us is the petrochemicals data, which tends to moderate with the process analytical instruments market. And let's compare that with organic chemicals, organic or inorganic chemicals, and then semiconductor and electronics. They tend to have a similar growth profile or similar trade profile. And if you were to separate out imports and exports, we see that we have a surplus in chemicals and a trade deficit for the semiconductor. So we're doing a pretty good job as US importers and exporters concerned, but not so good for the semiconductor market. I wanted to share some fun facts about the manufacturing sector. Manufacturers consume about a third of the nation's energy. Petroleum and natural gas represent 3/4 of the consumption. There are about 13 million manufacturing workers. For every dollar spent in manufacturing, it adds about $2.60 in overall economy. Manufacturers account for more than half of R&D spending. Pharma represents that lion's share. Okay. And then here, last year I talked about the 80-20 principle and presented some data about retiring workforce and the manufacturing industry. We tend to be a little bit age heavy on the older side, and I wanted to see if there was any significant difference. And this. Did you know what percentage of the chemical manufacturing workforce identify as boomers? And if you said 20%, you're right. But by comparison, this is a big shift in the overall market. So boomers are retiring, Gen Xers are being fired and laid off. Hopefully this is not because what I said about them last year. But from what I remember, me identifying as a Gen Xer, were about 40% of this. Now we're at 34%. So lots of hate for us Gen Xers. So I want to appeal to you hiring managers. Remember that the X in Gen X means experience, and the M in millennials means more mistakes. So the little Matthew, will forget to turn on that analyzer, and you're going to run into problems. Anyway, so how does this relate to our industry? So if you're producing a product or designing a product, you better be designing it for the millennial. Also, you should also think about servicing, right? So servicing, a lot more mistakes coming forward. So if you pay attention to your service numbers, you should pay attention to your service numbers, yeah. So those will likely increase. Okay. So this might be familiar to you. This is Gulf Energy information. It tracks projects, the hydrocarbon processing industry. We like to track the trends of total active projects, the dollar value, and the percentage of pre-construction in phase. So changes in these values gives us clues what lies ahead in the process analytical market. So over the last 2 years, you'll see robust expansion, the gas processing, that's green. Petrochemicals, orange, and refining, the blue. Overall, not as good as 2019 and 2020, but rebounding nicely from COVID, from the COVID lull in 2021 and from that Russia-Ukraine war when that started. Okay, here. So here's how the $2 trillion is divided by geography. Looking at the chart on the right, North America tends to be LNG focused. Not a lot happening in EU. Eastern Europe tends to be focused on petrochemicals. Asia continues to invest across all sectors, but large shares coming from refining and petrochemicals. Middle East tends to spend their investments evenly across 3 sectors there. Okay. Here's world energy. World energy outlook for till 2050. This data is a bit old, published in 2023, but it shows direction of energy consumption. Essentially, the goal was to dramatically increase use of renewables, use significantly less coal, and reduce liquid fuels. On the right, you can see how they predicted energy consumption by geography. Asia will consume half of the energy by 2050, and mainly due to manufacturing and transportation expansion. So those are the drivers of growth. It'll be interesting to see what they say later this year, considering we are moving toward a protectionism and reshoring society. So what are the tariffs telling us in this globalization strategy? So really, the economy of scale is no longer viable. Do one thing great. That's essentially what it is. Do one thing great and scale it. So that's not what the administration wants. We want right now. We want to bring things closer to the consumer. So it's at that closer to the consumer concept. So build things smaller and closer to home. Okay, switching gears, now we'll look at the vendor survey we did. So we did this in March, April timeframe. So this is before things started to change for us. So we asked the question, in terms of units and revenues, how did the business change from 2024 compared to the previous year? And this is what the survey said. So, just to quantify here, no change is plus or minus 3%, decrease is negative, and the increases are plus 4 to 7%, and significant increase is more than 8%. And so what we want to do here is is establish a baseline. And we use the similar algorithm that the Purchasing Managers Index uses, where we assign points to the scores, and we generate an index here. So 0 points for decrease, 0.5 for no change, and 1 point for increases. So this is the baseline for 2024. So 65, just to remember that number. Okay. So we asked the question, what are the positive economic factors and trends that are shaping our addressable market? So positive trends are new plant construction, increased production, and delayed projects from before now moving forward. So for me, I want to see numbers that are above 30%, and so that's 1 in 3 respondents. So anything in that 40, looks like, what is that, 48, 40, and 50%, those are nice numbers there. Here's some other things that they mentioned: increased oil prices, carbon capture, government economic policies. So these are all positive trends. Okay, on the contrast, let's look at what they said that are negative factors. So what's pulling it down? Big one there. So customer budget constraints and tariffs. So huge percentages there. Here's some other things they mentioned: oil prices, challenging reaching customers. Okay. In terms of units sold, how do you expect company business to change for the following end markets? Okay, so this is interesting. So we put in that baseline of 65% or 65, so that for that index, and so that is what we expect to see in terms of growth. So we see positive trends for the chemicals, electric power, not so much for food, metals, minerals, pretty good, natural gas, okay, I mean, it's doing okay, but the semiconductor and water markets tend to be doing pretty good. Okay. And here it is by geography. So North America, Europe, Western Europe looks pretty good. Rest of Asia, pretty strong, and I think a lot of that is because of India. Latin America, pretty good, and Middle East, Asia, Africa. So very good there. So in terms of units sold, how do you expect it by application? And so we look at it sort of more broadly for application. So we look at process monitoring as QC and emissions monitoring and safety. And obviously, we're more into that processing market, and that's what's driving that growth. Okay. In terms of revenues, how do you expect your company's business to change in 2025 compared to last year? So this is forward-looking. So this is the numbers. And remember what we did with establishing that index. So 66 in terms of revenues. We're looking pretty good. So a lot of optimism out there. So very good numbers. So very exciting for us. So now let's take a look at our market, the process analytical instruments market. And just sort of background, the instruments market is about 6% of that global enterprise of what we will call $750 billion. That includes end users, all the money that's spent by end users, by EPCs, the instrumentation manufacturers, and process control systems. And for us, it's about 46 billion as in terms of enterprise. So we're looking at sort of 4 years in total, and that cumulative value, that's what that number is. Okay. This is how we break out the market by technology. We'll look at chromatography, photometers and spectroscopy, liquid analyzers, oxygen combustion, moisture, industrial mass spec, advanced analyzers, and some other technologies. So by end market, this is what it looks like. We look at the petroleum market, we have chemicals market representing about 40%, pharmaceutical market 12%, the semiconductor market, which is put into other, about 14%, metals, minerals, about 7%. Utilities is a big one, 20%. Here's the breakout by geography and by product. North America, 20%, Europe, 26%, China, 18%, other Asia, 22%. Yeah, if you do pay attention to Asia, look at India for now. Okay. So getting closer to the end here. So the global PAI market, products and services, we did an index of looking at some macro data, and we do it by quarter. And so because that's the way the data is published, and so we did a regression on the data and see how it tracked with our industry, and so we can. And I was surprised at how close we are with the industry. So it tends to work. So it's kind of neat for me. So as an analyst, it's really cool. So this is what it looks like. Well, you can't really see, but so we're estimating the market to increase 2.9% or roughly 3%. For overall. Okay, I'm gonna skip. Okay, so just some key takeaways. I want to revisit the macros and our vendor survey. So macroeconomics, we saw some strong momentum coming into 2024, feeding into the 2025 with the return to work economy. So that was what I feel like was driving that market. We have short-term disruption in the market because of the tariffs. It's a mix of panic buying and the pause in investments. The US dollar is becoming less strong. So notice the words there. It's not weak because it has been very strong the last couple of years. So it's less strong. Low oil prices are impacting capital investments and the energy sector, and then the stagnant number of HPI projects. So the vendor survey, positive factors is really the new projects. The negative factors is customer budgets are tightening up. PAI manufacturers are optimistic, and the chemicals and semiconductors were expected to be good, especially in North America, Asia, Middle East, and Africa. And consensus is market disruption, really the geopolitical disruption with the trade war with China, their sustainability goals and deregulation, technology advancements using AI. I didn't really touch on the batteries, but that's playing into the market. Hydrogen energy and carbon capture storage. So those are things that are disruptive in some capacity for our market. And then overall, we expect modest growth, higher instrument prices in line with inflation and tariffs, and then lower volume of units shipped. So yeah. So if you think about our industry and how we manufacture products, all the raw materials are going to increase. So that's the main reason for that increase. Anything with a magnet, anything with a motor, prices will increase. Okay, and then want to finish with some questions that. Sort of interesting to me, so as Americans, we have a spending problem. Our national debt is 36 trillion and counting. What percentage of households are in debt? Roughly 77%. So yeah, that's the American way. And last question, EVs are steadily gaining traction. So what percentage of new cars are EVs and full battery plug-ins? 22%. So, and in fact, full battery EVs, the adoption rates are much better. If you look at globally, it's 14%. US is only at 7.5%. Europe is at 14%. China is at 27%. And Norway, leading us, is at almost 90%. So very, very interesting statistics here. So these are sort of some big trends, and with that, I'll just, if you would like more information, you can request the data, and I'll be happy to talk to you. And yeah.
Anybody have any questions for Glenn right now? Oh, we have one. Step up to the mic.
Thank you for the presentation, Glenn. I am quite curious. So a lot of the charts about the business insights, for some of them you have properly sourced information sources. You've credited them. For some not. So I assume that for those that were not, you didn't specify sources, those were coming from your surveys. Would you be able to share with us, give us some insights onto the nature of these surveys, how these were conducted, and particularly when getting responders to the surveys, how do you make sure that the respondents would reflect the nature of the whole industry, and you don't have a situation where you are actually getting a bias where the responders are coming from a limited part of the industry, and then which would make the mistake of the results of the survey would actually be falsely generalizing to the whole part?
Yeah, actually, good question. So to kind of preface that survey, the vendor survey, we actually ask about like what they're involved in first. And then from that, we ask about what they see, particularly for their business. And so if we see their particular business increasing, decreasing, or no change at all, we are sort of putting that as a framework for that particular technology. So yeah, it is important to understand that. So every technology will have a different set, but for this presentation, I did combine the data set. I didn't want to break it out because we're looking at an N of about 50 responses. So that's not a whole lot of data. So when you parse it out by the different technology types, for example, then it will sort of skew that the results. But taken as a whole, I think it does create that outlook that is doing pretty good. And if you look at the PMI, the Purchasing Managers Index, and that's what they do. They're looking at manufacturers from all over the different sectors, including semiconductors, chemicals, metals, anything that they're sort of manufacturing things. That's what they're using. So you can look at it overall and still make a good sort of estimate of what's happening in the market. So yeah.
Thanks.
So just if you do request information, I am asking at the end of that survey to complete. So I wanted to see if it would be possible to create like a PAI sort of advisory board or advisory for market data advisory. So if, every, I don't know, maybe 6 months or so, I would like to pulse the market and see and publish the data, and I'd love your participation in it, in a sense of like, if you are a manufacturer of instruments, process analytical instruments, I would like you to participate in this. So I'm calling for that. Yep. Thank you again.
Okay, so whilst we tabulate scores and put together the final closeout information and data, we've got about 30 minutes. I'd like everybody to come back, reconvene at 3 o'clock, where we are doing closing. And also, we have, he's not here, is he? We have a special presentation at 3 o'clock that it would be really great for everybody to attend. I think you'll get a kick out of it if you do. So back at 3 o'clock, please. Thank you.